Hey champions, welcome to the next in the series. We have been looking at regression as a key technique to solve multiple problems, and today we will continue with step 5, right? So just as a quick refresher, we looked at the first step being understanding business objectives. What are we trying to achieve as part of our prediction, right? What is the prediction capability I need? What are the challenges I am trying to go after, right? Second is being able to acquire this data. We looked at a couple of options. Now, data acquisition is not a big problem in this case because here the data was already provided as part of a Kaggle competition or so on. But nonetheless, that's an important step I like to include as part of. So acquisition cannot be underestimated. It could be a bigger problem. Okay. So then we talked about step 3 being exploratory data analysis. You trying to get a good understanding of the data set, what's provided, what are the distributions, and so on and so forth. So both visual and statistical analysis gives you good power in terms of being able to understand, right? Then we talk about building the data for the model, right, as well as the basic model, right? So the core is data preparation. So data preparation, as we've seen, we may need to scale the values, we may need to address the missing values, and so on and so forth. So we've gone through a set of steps so that finally I have a data file or a data input that's ready to be fed into a model, right? And we can then start to look at running the models and so on. So we looked at two parts. One is this data preparation aspect and then the model building aspect. We talked about using two set of models to be built at a minimum, right, or multiple models to be built for a problem, and then look at what kind of scoring we get and so on. So we looked at linear regression and random forest as two methods, and we got some scores. Although random forest did better, but both of them were closer to the 65% range or so, right? They were not performing the best. Okay, so then that's my initial first round of observing the performance and so on. Okay, now we go to the next step, which is really a good step. So model building is an iterative exercise, and finalization, building and finalization is an iterative exercise. And one of the things we try to do is we try to see how I can improve the score and the predictability of the model, right? How can I make the model better and so on and so forth, right? So we've looked at the first 5 steps, and now we look at step 6. Now you essentially are going to do a couple of things, right? You're going to take parameters which you can tune as part of the model, or you look at combination of models or different model techniques. So there are various approaches to performance tuning, and it's really depending on your understanding of the data and expertise to tune and so on and so forth. Okay, but largely in this case I'm going to look at two things, right? I'm going to primarily see if I can make any adjustment to the model itself, but primarily I'm going to look at features engineering or features scaling as feature engineering as one of the key techniques, right? So given the input, not all the attributes are equally impacting my target value. So first step I'm going to do is, one technique I'm going to do is try and see if there are columns that I don't need to include in the model, and will that improve the performance. Second is we're going to compute set of features and then use that features, right? So those are the two things, and you could do other things, but essentially this is what it is. And then typically we try to compare the model outcomes from the various versions of these models that we would have run. We can have various combination of attributes and tuning and features, and see which one performs better, and then finally select the one that needs to be used. Okay, alright, so that's the step that we're going to look at here. So if I go to 9 now, we already looked at till model 5, and I have written the data to the file and table, and this is familiar to you now with all these attributes that are coming in from the file, the lat long parameters and the log linear values and so on and so forth, all of that good stuff. Okay, alright, now let's just take that as an input and go with this step. So like I said, right, so now we got a base model, and one thing I've done is I have gone ahead and save the values. So this is my linear regression and I'm saving these values. The scoring is named as, give me 1 second. So I've named the scoring as median housing value predicted underscore LR for linear regression, right? And then for the random forest, I would have named it as predicted underscore random forest, right? So this is the base model, and then I'm going to write to this, and then this is written as a file, and I can look at the file and so on and so forth. Okay, so these are my two columns, and then I've written that to a file, and the file is here. If you look at it, you can see that the file is version 2 within the current data area or whatnot, right? Now how this is going to help me is, as I'm running different versions of the model, I can keep accumulating the model results, and I'm just trying to keep it simple by writing to a CSV file. It could be a table, it could be other things, but you accumulate these values and then finally you can compare and go from there. I'll show you that in a minute. Okay, all right. so we have the input, we have set of round 1 of models that have been built and scored. Now I have to go back to the core input and see what else can I do, right? So we talked about taking the input data and doing like a feature engineering. So what could be the feature engineering options there, right? So we have certain information. So in this case, we have talked about one of the features I thought is, we've been given number of rooms and we have the or aggregate number of households. So can I look at average rooms per household, right, as one of the features? So it means take the total rooms that are there and then divide by the number of households. So this is like a simple formula, and whenever I apply this will apply to each of the rows, and then you can see the values, right? So now if I apply this, you will see that there's a column that should be available, whatever is the naming I would have given to that, and it's usually the last column. So rooms per household is one of the features we have created. Now similarly we can create one for bedrooms per household, right? So it's the same concept. I'm just creating another feature and I'm keeping them separate so that it's easy for you to understand. So we're just going to append a new column saying XYZ. You could label it as features or whatever it is, right? So we can go creative on those kind of things, but by and large you will see that now bedrooms per household is another feature that have come in, right? So mostly there is some missing value because we are dividing. There could be row 0 and stuff like that, right? So I'm not going to worry about it too much now in terms of handling, just to keep it simple. So all I'm saying is, let's go with the basic. Now I have a feature works for multiple of these, and I can handle some zeros and so on and so forth. Look at it, but we'll continue. Okay, all right. So now what I'm going to do is the second technique. So one is create the features. Second is be able to use the columns that are relevant. So having run the base model, I get to see that certain columns are not of value, and they're not necessarily going to help me in the final housing prediction, right? Or you may from business know that the certain columns are not going to be of value, right? Okay, so now I'm removing, so I just use column filter as one of the options. I remove lat long, for example. I'm just choosing that as an example just to remove these. And then because I already have something to indicate the location to say, hey, is it near the ocean or not? Is it inland? So I already have some indicator. I'm removing lat long. Now that could be a mistake, we don't know, but as part of your fine tuning, you could test that as well, right? So for this part, as an example, I'm just removing these two, and then I'm saying also total rooms and total bedrooms. I don't need that because I'm now using the new feature that we have created, rooms per household and rooms per bedroom. And I'm keeping the household as an example because I think sometimes the number of households gives me a better, because it's a reflection of the density of a region, right? So that could be a parameter, that could be a value. Okay, all right. So you could filter the values and then use then apply missing values. We had some 1 or 2 rows that had missing values, so I'm just removing that. And then it's about train test split, give the 70% and the 30% splitting of the values. Okay, then it's the same concept, so I'm going to apply now fine tuning. I've done it as a separate step. You could have done looping and other things with the previous step and so on, but to keep it clean and because we are trying to understand and learn, right? So I've kept it little step by step so that you can understand. So it's the same repeat of the same linear regression model, but from a learning standpoint, this gives you some clarity, right? So now I'm passing the new input, which is where there are two new features. I've removed certain columns, I could do other things, and finally I get these models, right? So here you can see I've run the learner, I've run the predictor as well, and the predictor would have given me a column which says, so I've labeled it as round 2, or whatever is the technique that you're using, saying features scaling, removing households per XYZ or whatnot. Similarly for the random forest, I'm doing the same thing. Round 2 is the column name I'm saying, and all that. Okay. Alright, so just make sure you're selecting the medium household, the target variable correctly, and then whatever you all these other columns will be there, and so on and so forth. Okay. Alright, so in this case what I've done is I've already executed all of this. So you can see column resorter is just to bring the columns together. The numeric scoring is finally these scoring values that you can see here, right? So this is part of the round 2 scoring, and then round 2 scoring again. I see this, and I'm going to now bring all these together and show you how we can kind of start looking at evaluating this. Okay, so now I can add a column sorter here if I had many of these results, and lay them one out, order them in a right manner and so on. But since it's only 4 columns, assume we'll just go with it and quickly look at it. Okay. Alright, so I'm just going to use R2 square as one of the key measures from this point, or even the error factors, one of the error factors, let's say root mean square error, or so on, and then I'm going to use that to see if I can select a model, right? So now R2 square, if you can look at it, we said it's a good predictor of saying how much of the variation in the model is explained by the model that we, how much of the variation in the predicted values is explained by the model, right? So that's what we're looking at. Now in this case, we see that higher the R square, the better it is, but we need to look at other factors as well. So just to keep it simple, I'm just saying, okay, so now when I did round 2 with linear regression, the improvements were not that great, but when I looked at random forest and I added those features and probably removed certain columns, random forest started performing much better. Okay, and then the error factor also dipped relative to, let's say, mean absolute error dipped, right, marginally or whatnot, right? So that's there. So with random forest, with the new features, I seem to have a better luck and better predictability, so to speak, and therefore I could choose this model and go with it, or I can further go and explore and look at the predicted values. You will actually do a little more analysis before even concluding all of this, right? So now you say, hey, okay, let me just look at random forest, and then let me now look at the predicted values, how far are the errors, for all the cases am I getting good results, and so on and so forth. Okay, so you can do some more scoring and look at the results and look at the residual value, which is the difference between the predicted and the actual, and then look at that error factor and plot, and you could do scatter plots and then look at it as well. Okay, alright, so now this gives you, we have gone through a full life cycle, and I'm going to bring it together. So this concludes the core of what we were looking at in terms of the end-to-end regression, and I thought it's good to keep it no code, low code, and still go through the concepts for those who are trying to get started. If you're already a statistician and an expert, this course may not be for you, but many who are getting started in this field, for them it's a good place to go through the end-to-end flow, and hopefully it's easy. You don't have to worry about Python coding and other things, and you can learn this, right? Okay, so let's go back to our mind map and revisit this piece. So essentially we have covered all the steps. I'm just going to go through the steps once more just to bring it together. So we looked at the big picture problem. We said, what is the problem I'm trying to solve? In this case, you want to look at the core business need, and then say, hey, what am I trying to achieve here? So in this case, I'm trying to I'm trying to see other methods to predict the price of houses or the median value of houses in a California district, right? So what could be the determinant of median value of the pricing in California and so on, right? And maybe I was doing this manually before. Now with statistical model, maybe I'll get better accuracy and results and so on and so forth. So whatever is your business driver, go with that, and then make sure your expectations are set in terms of, what am I going to measure in terms of performance, cost, and other bits, right? And what are the this is important to understand what are the other alternatives, right? So I could go to experts, I could collect data every time, or market research and so on, but not possible to do this all the time, right? So with a lot of AI and ML coming in, we could really automate some of this if I had good data, right? All right, so that's the first step. Then we talked about acquisition. Now acquisition in this case was not a big thing, but there could be situations where you may have to go to the different sources and talk to the owners, get the values, or if it's external sources, you may have to integrate, even build a data platform. That's the job of a data engineer and so on, and they will be able to get you that, right? Okay, now that I have the data file, I'm going to do a quick analysis, try and understand what the data elements are. What do I have? Numeric data set, categorical, how's the target variable, what is the distribution, right? What values correlate with one another. Get a good sense of all of this. So we've seen the big picture. What are the attributes of the input file, rows, columns, what are the mean, median, statistics. So looking at the descriptive pieces and so on, right? There are multiple things I can look at. So measures of central tendency, dispersion of the values, the skewness, all of this will give you a sense of how is the data, what's the distribution, and so on and so forth. And you tend to do that both visually as well as statistically. So I work better with visuals. So for me, that works better. So I look at histograms, distributions, pie charts, and so on. For some, just looking at the statistical values, you may get a better sense as well, right? So I tend to look at both the combinations, so it's easy, and we can also explain to clients when we are working with them with the visual analysis. All right. Okay. And then we talk about bivariate analysis, where we look at the relationship, the correlation between attributes there in terms of the input. So that's your crosstab analysis or covariance matrix. All of these are going to be able to give you what is the relationship between age of the house and the price, or age of the house and the number of households. All of these factors. So we just get to see the results as a matrix, and you get to see like a heat map, and you can determine if things are heavily correlated with each other, then you can remove those attributes and work on rest of them. Because if two attributes are highly correlated with each other, then I really don't need to include both of them in the model, right? I can reduce the number of attributes the model has to worry about. Alright, so now I have a good understanding of the data set. Now I go and prepare the model. So as I prepare the data for the model, So as part of the data preparation, we do go look at various things like missing values and looking at categorical values and converting them into numerical. One-hot encoding is something we saw. Feature scaling is important. Make sure all the attributes are in the same unit, and so on and so forth. And then we finally do the train test split as well, and make sure there's train, either you could do train validation and test, or train test to keep it simple. In this case, we just did 70-30 or train and test. Okay, so that's your data preparation. Now that I have a good data set ready to be fed to the model, in terms of all the categorical variables have been converted into numerical or encoded values. We also created categorical based on a numerical range, which is your, I think, income grouping or so. So that becomes a feature that I can work with as well, right? So you created a feature here, but then I will look at the features later as well. Okay, so prepare the data now. Then all you're trying to do is look at what are the models that I can run. So this is the regression technique, because I'm interested in a specific value, which is the price, So I'm going to use various regression techniques that's available and then train the model and then start to analyze the model outcome. Right now, I will share this mind map with you, so you will be able to see that I can look at, in terms of model evaluation, I can look at R square as well as root mean square value RMSE as well, right? So it's nothing but a square root of the difference between the predicted and the actual, and you can look at it now. RMSE is going to be sensitive to the outliers and so on and so forth. I think I've covered that at the beginning on one of the videos, so you can look at it as well. But essentially, then we look at mean absolute error or RMSE, one of these error factors, along with the adjusted R square. Okay. Then I typically also plot the residual, which is the model will give me predicted values, and there is already an actual value in the test data set. And with that test data set, we can look at what is the level of error, the difference between actual and the predicted, and then that residual plot can also be of value. You can see the distribution of the error. Is it too high, too bad, or is it closer to a certain range, right? Within 10%, 20%, whatnot. You get a sense of that. Okay. So once I analyze the outcome, right, model outcome, which is an important part of it, then I can go and look at other aspects in terms of is the accuracy acceptable to me, is it overfitting, and other things, right? So those kind of things you may have to evaluate the model before jumping into deploying the model. Okay, so all right, so now we have built the model. Now I go and, as we were discussing, it's an iterative process, so I'm going to go and fine tune the model, which is what we saw in this video, where we looked at adding new features, removing certain columns, maybe correlated columns, maybe attributes that you think are not useful in the final model, and so on. And you can do all of that multiple times and evaluate these, and finally tabulate all of these rounds or iterations of results, and then you can go and select the ones that seem to perform better and acceptable to you, using combination of R square plus error factor and so on and so forth. Okay. All right. Now we've kept the process to more of linear regression and so on and so forth. Now, if the problem demands, let's say, if the relationship is not linear, if it's let's say so let's say the price goes up linearly up to a certain point, and then it exponentially grows, or it tapers or whatnot. So whatever is the behavior of the price, we can relative to the other factors, we can see if it's a log linear type of relationship or other kind of relationship, then you may want to model that regression accordingly and so on, right? Okay, so all right, so we've gone through the full life cycle. Hopefully you are comfortable in terms of being able to take a problem, walk through end to end, and then build the model and finally go to business with it, right? Now, one thing we have not talked about is how do I make it an application and so on. Now that we have the model, there are techniques to go and take the model and then expose it as a service and make it part of a business application and a pipeline and so on and so forth, right? So there are other things that you may want to worry about in terms of how do I make it usable. In fact, this part of the thinking has to be part from the beginning as well. What is going to be the use? How is this model going to be plugged as an application and so on and so forth, okay? But most likely you may, at a minimum, you can expose it as a REST API or a service where I can feed in the new attributes for the new district. Let's say I'm trying to predict the value, and then the service returns me the expected price using the model, right? So that's one approach that you can look at and keep it simple and all of that, right? So, and then you can make it as part of an application pipeline, whether it's part of the sales process or somebody who's trying to plan and strategic planning in terms of entering the market or whatever it is, the business scenario. Try and use that, okay? All right, so, and once we finally deploy, we obviously have to look at monitoring this ongoing basis and all that. So there's a whole lot of other things we need to do even after we get the model, right? So, but the video will become too heavy if I continue to keep explaining all that. But for you to get started, you get a good sense. Hopefully this mind map helps you get a step-by-step process and how to go about these things, and how to approach and a structured approach to this. Now the same structured approach applies even when you go to neural networks and so on. Things will differ slightly, but by and large, there could be data preparation, there could be other things that you have to do, the model life cycle, evaluations, and many of these steps are standard. So I would say internalize these steps and try and do a scratch, try and work on a problem from scratch using a structured approach, and feed your comments. If I can make it any better, then I'll be more than glad to do it, and it's a learning process. There's a lot in terms of details that we can keep going, but all the essentials I've covered. That's what I believe in terms of what, based on my experience working with clients and so on real projects. So core of this is what I've covered for somebody to get going and how they can go with it, right? Now the real projects may have lot more data engineering work, lot more visualization, lot more pipelines from building the model and so on. But from a data science standpoint, most of what we talk about, the iterations and so on, we have gone through, we have covered that, and you will be working with other members in the team to kind of bring everything to life in terms of an end application for the user. Okay, I'm going to pause here. Hopefully you like the video, you like the entire series. It's a 4-part series. As you can see, it takes a little bit of deep dive of learning each of the building blocks. So the 4 building blocks. Hopefully it's been a good learning. Please share your comments, and if you learn anything, do share your learnings as well. It helps others. That's how I look at it. Anytime I look at a video or a learning, my learning could be different from others, and that itself is a big part of the sharing and the learning that helps. Okay, subscribe to my channel and then feed your comments. We'll see you in one of the next series, which could be classification or deep learning, NLP, and other pieces that I put out. Okay, thank you very much. Bye bye.